Welcome to the online class BSc 4th semester diffraction session 6. Here in this session we learn about the transmission grating. So introduction to transmission grating. In optics, a different grating is an optical component with a periodic structure that splits and diffracts light into several beams traveling in different directions. The emerging coloration is a form of structural coloration. The direction of these beams depend on the spacing of grating and the wavelength of light, so that the grating acts as the dispersive element. Because of this, grating are commonly used in monochromators and spectrometers. A grating has parallel lines, while a CD has spiral of finely spaced data tracks. Diffraction colors also appears when one looks at bright point source through a translucent fine pitch umbrella fabric covering. Decorative patterned plastic films based on reflective grating patches are very expensive and commonplace. Theory of transmission grating. At any given point in space through which diffracted light may pass, the path light to each slit in the grating varies. Since path light varies generally, so do the phase of the waves at the point from each of the slit. Thus, they add or subtract from each other to create peaks and valleys through additive and destructive interference. When the path difference between the light from adjacent slits is equal to half of the wavelength lambda by 2. The waves are out of phase and thus cancel each other to create points of minimum intensity. Similarly, when the path difference is lambda, the phases add together and maxima occur. For a beam incident normally on a grating, the maxima occur at angles theta m, which satisfy the relationship d sine theta m by lambda is equal to mod m, where theta m is the angle between diffracted ray and grating's normal vector, and d is the distance from center of one slit to the center of adjacent slit, and m is an integer. Comparison of the spectra obtained from diffraction grating by diffraction 1 and prism refraction 2. Longer wavelengths are diffracted more but refracted less than shorter wavelengths. Thus, the light is normally incident on the grating. The diffracted light has maximum angles theta m given by d sine theta m is equal to m by lambda. It can be shown that if a plane wave is incident at any arbitrary angle theta I, the grating equation becomes d into sine theta I minus sine theta m, which is equal to m lambda. When solved for diffracted angle maxima, the equation is theta m is equal to arc sine in the bracket sine theta I minus m lambda by d. Please note that these equations assume that both sides of the grating are in contact with the same medium. Example, air. The light that corresponds to direct transmission or specular reflection in the case of a reflection grating is called the zero order and is denoted m is equal to 0. The other maxima occur at angles represented by non-zero integers m. Note that m can be positive or negative, resulting in diffracted orders on both sides of the zero order beam. This derivation of the grating equation is based on an idealized grating. However, the relationship between the angles of the diffracted beams, the grating spacing, and the wavelength of the light apply to any regular structure of the same spacing, because the phase relationship between the light scattered from adjacent elements of the grating remains the same. Examples: Diffraction gratings are often used in monochromators, spectrometers, lasers, wavelength division multiplexing devices, optical pulse compressing devices, and etc. Ordinary pressed CD and DVD media are everyday examples of diffraction gratings and can be used to demonstrate the effects by reflecting sunlight of them onto a white wall. This is side effect of their manufacture as one surface of the CD has many small pits in the plastic arranged in a spiral. The surface has a thin layer of metal applied to make the pits more visible. In standard pressed vinyl record, the when viewed from the low angle perpendicular to the grooves, a similar but less defined effect to that in a CD or DVD is seen. This is due to viewing angles and the path of the light being reflected due to this is being changed by grooves, leaving a rainbow relief pattern behind. Diffraction grating are also used to distribute evenly the front light of e-readers, such as the Nook Simple Touch with glow light. In figure, we see the transmission grating working diagram. Transmission grating experimental demonstration. Determination of wavelength of spectral lines of white light. Monochromatic light is now replaced by a given source of white light. The source emits radiations of different wavelengths, then a beam gets dispersed by grating and a spectrum of constituent wavelength is obtained as shown in figure. By seeing the figure 5.23 diffraction of white light, knowing capital and wavelength of any line can be calculated from the relation lambda is equal to sin theta divided by capital N into small m. Questions. Question 1. A grating has option A parallel lines, option B perpendicular lines, option C no lines, option D none of the above. Answer is option A parallel lines. Question 2. Diffraction grating will dash light. Option A converges, option B combines, option C diffracts, option D reflects. Answer is answer C. Option C diffracts. Question 3. Grating are commonly used in option A monochromators, option B spectrometers, option C lasers, option D all of the above. Answer is option D all of the above. Question 4. Everyday examples are diffraction gratings are option A mobile and TV, option B CD and DVD, option C memory cards, option D none of the above. Answer is option B CD and DVD. Thank you.